So thank you for coming here, especially after lunch and Spanish. I know what siesta means, so thank you for the effort. I'll try to have you engaged and happy with this. My name is Javier Ramirez. I'm a technical evangelist for AWS, and that means that Amazon is paying my salary, but I really work for you because my team, my mission is basically to give you all the information or the support you need to understand what we offer in our services and to help you see if you want to use them, what's the best way to actually achieve the business goals with our services. It's also my mission to understand if what we are building makes sense for you. So if you have any feedback about the products I'm going to be talking about, also about any other product, but in particular about data products, it would really help me if after the talk you can talk to me and you tell me if you had like a magic wand, what would be the thing that you will change and will make your life easier, because I can pass the feedback to the product team and maybe we can iterate and do something better, okay? So that's my Twitter. If you want to complain about something, if when I do the live demo, in the end, it doesn't work and I'm crying, that's what you have to mention. That makes for fun, and my mom is following me on Twitter, so it's very cool. I'm going to be speaking about building a modern data platform, and if you're interested in this, there are a couple of sessions that probably you want to attend. One already happened, the other will be later today. And we are going to be speaking basically first about the challenges of working with data in general, then about how you build a data lake using S3, how you transform data, how you analyze data with our products, and how you create a dashboard. Then we'll have our friends from Micropole and Vu. They are going to be presenting a real use case in which you can see how they are using these products actually to build something interesting. And we'll have the demo at the end, so we have the opportunity to break things and see how things work in real life, okay? Quick show of hands. How many here are already working with data, with analytics, doing data engineering? Okay, a few of you. I don't know if you are very shy or if I have only about a 5% of the audience working with data. So if you don't have any experience with data, you might have this ideal image. Working with data is very cool. I'm going to work creating fancy algorithms to process data, like in the movies. I'm going to be a hacker, blah, blah, blah. In real life, it's not like that. It's much more interesting. So I've been working with data for a while. And this is like a brief opinionated history of what was working with data for me. Before 2009, my problem was I had this database, and if I wanted to run reports, the reports would make my database very slow. So, okay, I have a second database, I do a copy overnight, and the job is, is fixed. Okay, that's not working now, my clicker. That's it. Okay, that's working now. So, my database will be like very slow, and that was bad. And then, and then 2009, suddenly we had this Hadoop thing, and Hadoop was going to solve all the problems. It was in the news in Spain. If you use, big data is going to make companies understand what you want before you want it. And I stayed waiting for that. But that was the promise. And but Hadoop was very cool, and I could use it for work with large amount of data, but it was very complex. It wouldn't really work for, for streaming data. So we have to use another fancy, another buzzword, like NoSQL. So let's use Kafka and Rabbit and Message Queue and NoSQL because NoSQL, hipster, that's cool, So I really love NoSQL. It's really cool, whatever that means, but it's really cool, NoSQL technology. So we use like NoSQL for streaming data, Hadoop for batch operations, but then I have like, two different ways of processing data, the batch way and the streaming way. And if I have to change something, I have to change in two places. It was like, this is not fun, but then came Spark. And even if you haven't used this technology, you probably know the names. Kafka, Hadoop, Spark. So it came Spark, and it could do many things. And I have been processing data for years. So what's happened in my organization, we had, when you have like a few hundred people working with data, it's like, you don't know which data you're already processing. You don't know if you have duplicates. It's like, is anyone already processing the data from the ERP? I don't know. And how often are we getting the data? Just in case, let's do it ourselves. So then you create a new department, data governance, and their work is basically manage spreadsheets to document everything that's happening. It might sound familiar, it might not, but that's the thing. And you get like, these fancy problems. And the more you move to the present and to the future, you see that there are like, many tools that you are using for, dealing with different things. And they are very interesting tools, but it takes a while to manage. It's quite difficult to work with those things. But the worst part is that it's not only about the tools. It's like, since creating a cluster with many different parts is hard, at some points I had the feeling when I was hiring engineers, that I was hiring engineers only to feed them to the data center. Will be data center, Hadoop cluster. Here you have a new engineer. She's not going to create any new functionality. I'm guys hiring her to work 24 hours, 8 hours, 10 hours a day. So she's going to be working 8 hours a day just to make sure the business is doing exactly the same, just at larger scale. That's not the best use of the time of an engineer. But that's the thing, that was happening. So you didn't have time for many other things. You were like worrying about things. Your cluster probably is busy on some peak hours, and then the rest of the time is not doing anything, but you cannot turn it off. If you turn off the cluster, start again, it might take weeks. So it's like, I don't know, this is not going to happen. So this kind of problems. But my personal favorite is that most of the time, I spend working in the small, stupid things that really, 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 really take all the energy out of me. I'm really scared of those things. If you tell me I'm going to pass you a test file, it's like, which encoding? Is it going to be a CSV? Okay, I don't know. How are you going to pass me an empty string? Is it going to be like an empty string in uppercase? Is it going to be like null, nothing at all? A binary 0? I don't know. What's that date? What's that? It's like the 4th of January 2019? Or is the 1 of April of 1999? I really don't know. And you probably don't know. If you know this, you can leave the room now. But you probably don't know that was 2 weeks ago. That's the time in Unix epoch of 2 weeks ago. But that's the thing. When you have data from different sources, you're going to have data that is coming in different formats, and you have to unify that. And it seems to be a very simple problem to solve. I only have to convert the data. It takes all of your time working in these small, stupid things. And if you are thinking, but this will be automated, you are right. It should be automated, but today, if you are working with data, people working with data that you told me before, does it resonate with you? Do you spend a huge amount of time in these small, stupid things that take, all your energy? Yes? No? Yes, I can see some people saying, yes, but my boss is here. I'm not going to raise my hand. So, I know. So that's the thing. So my goal today with this talk is helping you understand how you can do data engineering analytics in a less scary way. And basically, that means using our cloud, so we can use our infrastructure and our managed services to do the same things you are doing, in some cases with exactly the same products you already know, in other cases with cloud-native products, to do data engineering analytics in an easier way. So all those, the small things, worrying about the scalability. If a machine goes down, I need to provision a new machine. That's very easy, but you have to do it. And if I'm running out of space, I need to add more space. Yeah, but you have to do it. And if I have to convert some data, I can, but you have to do it. So we can take care of all those things, so you can focus on actually doing something more interesting. So that's what I'm going to be talking about today. And of course, it's not that I'm telling you, oh yeah, I work for Amazon, and yeah, of course we are cool. There are other people in every sector, like, finance, hospitality, of course, public sector, government, that are using already our platform. I'll show you later another example, and then we'll have, partners and customers speaking about how they're using this. So, if we are speaking about a modern data platform today, the first thing we have to talk about is a data lake. A data lake is a place where your data goes there, and you basically put data from different places. It can be from your database, from your ERP. It can be, some companies can be log files. It can be emails from the customer service. It can be actually recordings from the support team when someone is calling the call center. So all the data you get in the company, you put it on the data lake. And then we'll have tools that can directly read data from the data lake to do analytics. But that's the first thing. And you can have a mix of structured data, like a database, and unstructured data, like a PDF or a voice or a video file. And you put everything on the data lake, and somehow we'll make sense of that. That's already a difference. In the past, when you were doing data analytics, you will have a traditional data warehouse in which all the data will have to be somehow normalized. On a data lake, you put all the data, and then we'll make sense of that. So what's a data lake? Which components you need to build a data lake? Well, first you need to have some way of storing the data, and I'll talk about that. Then you need to have some way of getting the data from your data center into the cloud. Then you need to catalog the data to make sure you are not duplicating anything. Then you need to have a way of actually doing analytics on top of the data and transforming the data. And if you are really hipster, then you can do some machine learning. I'm not going to be really covering machine learning. There was another session for that today. But I'm going to be covering all the other areas of what we can do with data in our platform. So the first thing is like, okay, I have some legacy. I have already, if you are thinking about building data analytics, you don't start from scratch. Usually you have already data somewhere. And you need to move the data into the cloud. How you move the data? Well, you have different ways, depending how much data you have and the latency you want to support. So one is like, okay, with Direct Connect, you can connect directly to our cloud. So you are only one internet hop away. So you're like very close. So you are going to be like, faster traffic and more secure because you are not traveling around the internet. Okay, good enough. If you really want to have like low latency, you can have something called the storage gateway, which is a device we put on your data center, so your servers can speak directly, read and write files to that device, but that device is synchronizing behind the scenes with the cloud. So your data is in the cloud, but it's also on your data center. You have like very low latency, but you are still synchronizing all the time. If you have some database like Oracle or Postgres or MySQL or MariaDB or anything, or some of these SQL server, then you can use the database migration service. Basically, it's going to take all the data from your database and export that to the data lake. And you can choose to do that only once, or you can do it continuously with change data capture. Every time a record changes on your database, that change can be propagated to the data lake without you having to do anything. And that works with databases that are already in our cloud or with databases you have on premises. And one of the services I really like, and actually we have today one of the booths in the exhibition area is about this, is a snowball. What if you have a huge amount of data? What if you have more than, 500 terabytes, a petabyte, 3 petabytes of data? How you move to the cloud? If you try to move over the network, it's going to be very slow. How you move a petabyte of data over the network? Slowly. So we have this snowball family, which basically we send you a cabinet, which has some large hard drives inside. So we send you by courier the cabinet to your data center. You connect directly your servers there. You transfer the data locally. You send it by courier. We connect it to our servers. We ingest the data. And that's much faster than going over the network. But it gets better. What's the largest hard drive you've ever seen? That's a hard drive. That's the NoMobile. Yes. If you have like petabytes of data and you want to move to the cloud, you can actually order the NoMobile. And we send, that's a hard drive. We can actually send you several of these if you need. So we send you the NoMobile. And part of the offer, the NoMobile has GPS and of course security. But if you want, we can also provide a security escort. So you have vehicles around. I haven't seen them, but I imagine they are like in black and seeing things like the bird is in the nest or things like those, which is like pretty cool, But that's the thing, but you really do that. And it's like, are people using this? Of course. Imagine you have satellite data, satellite images, and you've been collecting for a few years now. You have really petabytes of data. That's a real use case. Some companies are doing that. They request there's NoMobile. We drive to the data center, and then you transfer the data, send it back, we connect, and you can move your whole data center to the cloud in an efficient way. It will be impossible to do over the network. So ingesting data seems to be well covered. We have different solutions, and depending where you are, you might be using one or another. Smaller data, just connect directly. Larger data, use some of the devices. Huge data, there's NoMobile, which is extra cool. So those things, and it's available also in Europe. It's not one of these fancy things that you see only in the US. No, actually you can request there's NoMobile in Europe, which is pretty cool. So what if you are streaming data, not just moving batch? You have real time because you are super cool and you want to do things as they happen. It might be the case that you're using something called Kafka. If you're around data processing, you try to have heard of Kafka. It's a very fast message queue. Kafka is super cool. I really like Kafka. It scales as much as you want, but it's not easy to scale. you have Kafka, you need to worry about things like partitions and clusters and many things that are not as fun as they seem when you have more than one server. Everything on big data works very well in one server. The moment you have two, it starts being like tricky. 3 servers, you want to change professions. So that's the thing with Kafka. It's very cool. It's very nice. Scaling is not that easy. So now we have the managed streaming service for Kafka, which basically allows you to use the same open source Kafka you already use, but without having to worry about the scaling. It's now in open preview, so the product is still not 100% finished, but you can already use it and give it a try and see if it works for you. If you are working in Internet of Things, which is another of the cool things now, well, you can choose to use some of our services to build that, or you can use IoT Core. IoT Core allows you to manage the devices, to get information from different devices at any volume, and to process the data as it happens. And then you can store that on any of our databases, or just do analytics on top of that. If you don't have any legacy yet, if you're starting with streaming, and you want to use something more cloud native, we have the Kinesis family of services. So Kinesis allows you to ingest data at any scale in a serverless way. You don't have to manage any server. Just start sending data, and if you send more data, we'll scale bigger. If you're sending less data, we'll just shrink, and that's the fire hose. It just moves data from point A to point B in a streaming way. If you want to stream data and at the same time analyze the data, then you can use part of Kinesis again. You can use Kinesis data streams. They allow you to ingest data and do something with the data as it happens. For example, normalize the dates, or for example, do anomaly detection. If you use Kinesis data streams, you can use just SQL on top of streaming data. It's very cool. You can say like, select the average of the, I don't know, how many products we are selling in the past minutes, and it's a moving average as it happens with SQL on a stream. If you need to do something more interesting, there is a Java API on top. It supports something called Apache Flink, which is an open source product. And you can use Java if you prefer to do more complex scenarios. And you can even use Kinesis for video streams. Basically, you can connect any video stream. Some cameras, they support direct connection to Kinesis. If not, if you have like any standard video format, you send the stream to Kinesis. And then you can process frame by frame whatever is happening. If you combine Kinesis video streams with our machine learning products, you can do things like real-time analyze who is in the picture, which is pretty cool. And that's what some TV channels have been doing to detect like politician faces and put automatic labeling, which is, again, quite interesting. So ingesting data seems to be covered. But where are you going to be storing the data? Well, I hope by now you are all familiar with something called Amazon S3. The simple storage service was the first service we released to the public a long time ago. So it's been growing quite a lot. We hold today trillions of objects, of files on S3. So S3 is a very reliable way of storing data. When you store data on S3, by default, we replicate always in 3 availability zones at least, and in 2 different regions. So you're not going to be losing your data. We provide 11 nines of availability. 11 nines means like it's going to be really, really, really durable. So 2 regions need to fail for you to lose your data. So that's quite big. It's very secure. You can encrypt your data at rest, in flight, in motion. You can use of course, auditing of everything that's happening. And one interesting thing that we added recently to S3 is that if you want to do analytics on top of S3, in the past, it wouldn't be very efficient. In the past, if you wanted to do analytics on top of S3, the analytical engine will have to read the whole file or a big part of the file before doing the analytics. So things could be slow, and not really slow, but slower than they could be. And they will be kind of expensive because on S3, you are paying for how much data you are transferring. Every time you are doing analytics, you have to read the whole file. Now, we support analytics in place. It means if you're using a format for the file which supports column partitioning, and you have an analytical query from S3 directly, we are going to be reading only the columns that you are using in the query. So you pay exactly only for the parts of the file that you need to read and nothing else. It's going to be faster because you are reading less data. It's going to be cheaper So it's quite cool. And S3 allows you to have like different, you have like lifecycle policy automation, and you can choose different classes of storage, depending how, okay, oh yeah, the screen is back. So depending how, depending the latency you want to achieve on the file and depending the access patterns, you can choose from different storage classes to be more cost effective. But what if you don't want to just have data that you access frequently? Sometimes you just want to archive data, like a backup or log files or some regulatory information you need to keep for 5 years. I need to keep the access logs, but I know I'm not going to be using them very frequently. Well, you can use the GlassHere. GlassHere is basically a storage, very similar to S3, but much cheaper. The thing with GlassHere, accessing the data is not as fast. S3 is very fast to access. GlassHere, it can take from minutes to hours. So if you are keeping log files from 6 years ago, and suddenly you need to read that log file today on GlassHere, it will take minutes or hours, depending how much you want to pay for the access. It wouldn't be latency in milliseconds, as is the case of S3. But it's for archive data. And actually, 2 weeks ago, we announced what you see there, GlassHere Deep Archive. It allows you to store data at a cost which is basically comparable with storing data on tape. Because we heard from many customers that storing data was expensive in the cloud. When you have petabytes of data, even cheap amounts, it can be too much. With Deep Archive now, the price you get is comparable to having tape there. So for those customers that were still using tapes because it was not cost effective, now, after 2 weeks ago, you can actually use the cloud for those things. Okay, so it seems like the easy things. Infrastructure is easy. You can just, I talk about ingesting data. I talk about storing data. But what about transforming data? The part where I told you I spend most of my time. Well, we have something called the glue catalog. Imagine your boss or your customer or you received today 2,000 CSV and JSON files. And someone tells you, oh, I have some useful information here. They might not all be on the same schema. It might be the case that the data started with one schema and has been changing, and I don't know what is there. So it's like, okay, sounds like fun. Well, you can create a crawler in the glue catalog, and you can say, hey, glue catalog, I have this bunch of files here on S3, make sense of them. So it's going to analyze, it's going to say, okay, this is a CSV, a JSON file, a Parquet file, these are the columns, these are the types, it looks like this. Oh, it seems in September this year, they add a new column. No problem, I'm going to document this. So the crawler is going to document the changes on the schema. It's going to detect automatically what you have there, and it's going to keep a catalog of all the data you have in your system. So it's very easy to discover. You can actually configure to remedy some problems. If it detects that a new column appeared at some time this year, you can instruct the crawler to actually add the column retrospectively to the older files, so they all have the same schema. Not too bad. And you do this serverless. You only pay for when the crawler is running. Okay, interesting. In the demo, I'm going to show this. But what if you want to just not catalog the data? You also want to run transforms, like removing some fields, renaming another, changing the type of something. Those are easy things. And you don't want to spend your time on that. Well, with the ETL service from Glue, you can create a transform job on Python or Scala. And basically what you do is you visually click on easy changes, and it generates for you the code to do the changes. And if you are familiar with ETL tools, you know graphical tools, they usually are pretty cool at doing things graphically, but they don't allow you to customize the code. So if you want to do something more advanced, you cannot. It's like all or nothing. ETL actually generates the code. It's PySpark or Spark code in Scala, and you can actually add anything you want to the transforms. So for the easy things, you do visually, and for the hard things, you can add yourself. And you can keep all the scripts and, and do whichever you want to do with that. And again, you pay only for when the system is running. You don't pay for any cluster or anything like that. So we know you can catalog data, you can transform data, and we have the first part of the data lake. We have already storage, we have archival, we have data catalog. Okay, cool. But what about analytics? Well, if you think about analytics, the usual suspect will be Hadoop. Hadoop is very cool, Hadoop or Spark, I told you before. I really like them. But the trend with Spark or Hadoop is that managing the infrastructure is not fun. Elastic MapReduce is our managed solution for Spark and Hadoop. Actually, it supports more things. It supports TensorFlow, it supports MXNet, it supports Apache Flink, it supports several frameworks around the Hadoop ecosystem that you can use. And you just create the cluster. You pay only for when the cluster is up. And the very cool thing about this system is that you can actually use S3 for the storage. If you are used to Hadoop, you know you have a cluster, and the whole organization is using the same cluster. So they all have to be running in the same version of the tools. And the moment you are a bit big, that's not manageable. The new people want to use the shinier tools. The people that have been using the cluster for a few years, they don't want to update the scripts. And everybody wants to use the cluster at the same time. The cool thing about Elastic MapReduce, you can use S3 as the storage layer. So basically, you can create different clusters. They all can share the storage. So you don't have to choose to have everything in one version. You only share the data across the clusters. You can start a cluster today, use some data, start another cluster, use the data. They can have different versions. They can have different tools. They can have different customizations. They can have different scalability patterns. And that's totally supported. So it's a better way of actually dealing with the standard Hadoop. Okay? What if you don't want to use Hadoop because it's too complex? You only want to do SQL at scale. You want a traditional data warehouse without all the hassle. Redshift is for that. In Redshift, you create a cluster. You ingest the data from the data lake, so you have to copy the data from S3 to the cluster. You pay twice for the data, once on S3 and once in the cluster. But once you have the cluster, you can run as many queries as you want, and it's very efficient, okay, at a scale. But some people, they have this use case in which the data is really big. They don't want to ingest the data into the cluster and pay twice, once in S3 and once in Redshift. For those people, Redshift supports something called Spectrum, which basically allows you to query data from S3, from the storage, directly without ingesting the data first. And it's fast. There is something in open source called Apache Hive, which allows you also to do exactly the same. SQL queries on top of storage. We did this when we presented Spectrum. We did this exercise. What if you had an exabyte of data? An exabyte of data. Yes. And you want to run SQL on an exabyte of data. A complex query. A few group bys, a few aggregations, a few joins. And you want to do this with Hive on an 1,000 CPU cluster. It will take poor Hive about 5 years. Because even with 1,000 CPUs, it's a huge amount of storage. An exabyte of data, a huge amount of input and output. We tried this on a Spectrum. Yes. We didn't try the Hive thing. The Hive thing is an estimate. We didn't have 5 years to spend. So maybe if you configure Hive properly, I really like Hive. If you configure it properly, you might be down to 3.5 years. But still, it's quite fast. So, but in this case, you still have a cluster on Redshift, and then you have a Spectrum for the other part. And I'm going to be finishing soon. I know I'm mentioning too many products. I'm going to be finishing soon, and then we'll have the demo. But what if you want to be fully serverless? You don't want to create any cluster. You only want to pay for the data that you are reading, and the data is already on the data lake. Then you have Athena, which allows you to do exactly that. You run SQL on top of the storage on S3 without creating a cluster. In this case, you are paying not for the cluster, you are paying for how much data you are processing. So how you choose between one or the other, it really depends. If you are running many queries over most of your data all the time, it's more cost efficient and faster probably to use Redshift. If you have a huge amount of data and most of your queries process only a small part of those data, it's probably more cost efficient to use Athena. So you can choose which one goes better for you. It's going to be a talk later today about how you choose between different tools. Cool, but I've been speaking only about analysis. And without a dashboard, if I go to my boss and I say, oh, this is the result, some queries, some numbers, it's like, what's this? It doesn't have any colors. I cannot click there. It doesn't, if it doesn't have a pie chart, it didn't happen. So if you want to have like a dashboard on top, you can use a number of partner products like Tableau, which are in the exhibition area, or you can use QuickSight, which is our solution to create dashboards automatically. And I saw that in the demo. So that will cover all the products we have for data analytics, or most of them. We are very secure. We comply, with a lot of different regulations. I'll show you now. You can, of course, encrypt your data at rest or in flight. We have a number of security products to work with firewall, with data exfiltration, with different issues you can find with your data. For compliance, we meet a lot of regulatory compliance, and we are working actively on getting more. So, we are always trying to get as much as possible. We scale quite well. I told you before, we have trillions of objects on S3, and we peak regularly 1 million requests per second, and that's fine. People like Fortnite, the people behind Epic Games, sorry, the people behind Fortnite. You know Fortnite? The game in which you kill people. My nephews and nieces are crazy with this. They have over 120 million players playing that game, and they have a very similar infrastructure to the one I told you. They use our services to have both streaming and batch analytics. So if it's working for them at 125 million players every day, it totally works, for most of you. So that's we can scale. We know how to scale these things. And of course, you pay only for what you use. And there are different strategies like using spot instances or SF instances to drive the cost even lower. I know there were like many things in the presentation. So what I'm going to do now is I'm going to set up, and I know you're going to be thankful for that. I'm going to introduce, one of our customers here, Vu and Micropole. That was the partner helping them. So Thierry Topin and Eric Lamal are going to present the use case. And at the end, I'll have a small demo putting together everything we saw. Okay?
So thank you very much. I am Flemish English speaker, so I'm a little bit slower than Xavier in my English. What we will cover today, we will in fact shortly introduce what Vu and Micropole are doing together on this kind of use case. What was our problem at Vu, why we choose the public cloud and why Amazon Web Services. And then we will also show how we build our own infrastructure, architecture, and how we use all these services in a real case. It's in production. The results and the next steps we are taking. So very shortly, Vu is a telco operator, part of the Natis group, also active in press and in utilities, so electricity and gas. So if you look at Vu is covering the south of Belgium and part of Brussels, a little bit the counterpart of Telenet in the Flanders. And if you look at our services, we are, let's say, offering interactive television, internet up to 400 megabit per second, fixed telephony, and mobile telephony. So we are a telco operator. Telco operator means that we have massive amounts of data coming out of all these systems. And that was, let's say, the problem we had to tackle. We sell our services in different packs. The most, let's say, large one is one which covers a 4P offering with all in it. Then I shortly give the word to our partner Micropole, which we constructed the case together.
Thank you. So just in one slide, so Micropole, it's 1,250 consultants helping our customers in Europe, spread over different countries. Let's say we have 30 years of experience in advanced analytics. We have a small team yet, but it's growing fast. We have 3 years. It's for 3 years. We are official partner of AWS. And let's say we are in the last mile of becoming an advanced partner for analytics. Yeah.
Okay, so the history of big data in, let's say, at Vu side. Well, up to 2014, a lot of things happened, which, let's say, was on the first slide of Xavier. Indeed, we had a kind of typical legacy environment, a lot of silo systems, data warehouses, all hosted on our own systems, so on-premise, where we had quite some troubles with capacity and performance on the systems. But up to 2014, I think it was manageable. So we had engineers, enough engineers to manage it. But then we had, let's say, in 2014, 15, 16, we had some business problems. In fact, we launched mobile service. Mobile, as you know, there is an enormous amount of data coming out of the services, SMSs, voice, data, and you have to exploit that, you have to bill for that. We had also a need to manage the data coming out of the network. So our network is a number of internet services and telephony services. There's a lot of data coming out of the network, log files and stuff like that. And also, we started with a new set-top box, so the interactive television box is producing a lot of data, because if you're zapping on the TV or looking at a chain in linear television, we capture all that data, we have all the data, and it is a massive amount of data. So at a certain point in time, we had an explosion of requirements on storage. We had a lot of performance issue managing this data. And we had, in fact, we were missing, let's say, a big data tools and environment. And on top of that, because we, at IT side, were not very, let's say, organized to deliver good service to the business started to build their own systems, their own ETLs, their own reporting tools, copies on servers, copies on PCs and Excel files and all the stuff. So the real thing maybe you have witnessed also. And that's a point where we really said, okay, we have to do something. Then let's say we had, it's only 2 years ago, in 2017, we said, no, it needs to stop, we need to find a solution. And then we asked our partner Micropole to make a study, and in fact, they come up with a proposal, not only to put in place a good architecture, but also to define a new organization and data governance structure within the company. And then, let's say, starting in June 2017, only a couple of years ago, we created a real transformation project to go from the old legacy situation to a complete new situation that we will detail now a little bit. There are 2 parts in this project, transformation project, we call it Memento. There are 2 parts. In fact, we put in place a complete architecture which enables us to put all data in one system, and all data processing and access will also be in the same system. And at the other side, we redefined the organizational structure. And I want to stress that second point. It's not only a technical transformation, it's also really a change management process, because the people used to use Excels and crunch their own data need to, let's say, learn to use the new tools with which we propose to them. So there is also an organization aspect you have to tackle. Then, let's say, the objectives of that, and for all of these objectives, we have now in production real cases. So we want to improve customer experience. Just a small example, we are now able to say almost in real time, detect based on log files coming out of certain technical systems to predict that a certain modem of a customer could fail in a couple of weeks, months, because there are certain patterns that come out of the system that we can manage, and we can then proactively replace the modem at the customer side. This is a very good example that was impossible to manage before, because the amount of data you have to manage is too big. We can better acquire subscribers, optimize operations. Also, the supervision center is using a lot of data analysis to detect proactive problems. The level of profitability of services, because we can, let's say, better sell and better improve our campaigns. The churn prediction improves customer retention. One of the biggest big objectives is also to predict that a customer could leave us because maybe he has some technical problem or he called several times the call center. So all this data is gathered to predict the possibility that customer will leave us, so that we can react and call him to that. And the last point was very important also for us, is the GDPR compliance. Probably you had a problem that your data was, let's say, all over the place in your company, also on PC. So the purpose was also to bring everything together and have people stop storage of local data on the system, so that we can control now everything with the tools of the Amazon Web Service portfolio. Why we use the public cloud? Like everybody, in this case, of course, internally in the company, they said, okay, why go to the public cloud? It's dangerous, it's not secure. it will be too expensive, we cannot control anything anymore. So we had to look at all the possibilities on premise with an infrastructure partner and so on. But at the end of the day, we convinced our management to go to the cloud, to the public cloud, where, because in fact, we wanted to be fast. Once the project was defined, putting in place service, it takes too much time. We didn't want to invest upfront a lot of money in it, because you never know whether it will really work. And also, we wanted to be sure that we could test certain tools and certain use cases. And if it works, we take it. If it doesn't work, we just stop it. And you cannot do that if you have to install all and you buy licenses and also install all these things. So we also had a need to use managed services, because we had some Hadoop and Spark and stuff like that, but we didn't find anymore the engineers, the people that worked on that. After a couple of years, they left the company because they had other opportunities. So we really wanted a system where we can exploit the data and not work on the technical part. So we said, okay, public cloud. And then why Amazon? Because not only because it's, let's say, the best ranked in a lot of surveys, but it really is, and I think it was shown by Xavier, it's really, let's say, from service point of view, from capabilities, from tools, the best thing we found besides the Googles and the Azures we all know. So that's why we take Amazon. So I now will give the word to Thierry, who will explain what we really use from all these tools.
Yeah, so that's a first not that technical representation of the architecture of what we built. Let's say that at the bottom we have really a lot of sources, like probably everyone today has a lot of sources of data with all their formats and so on. The objective is to go to the user and to better serve the user with this data. So to get there, let's say there are two big steps in the presentation. So we have first the data lake layer, where we're gonna collect all that data. We will have long-term persistence as well. But from there, we will expose it to the next layer, the enterprise data warehouse, where Amazon Web Services has really a strong offering with Redshift. So why these two steps as well? Because the data lake is storing all this information in its native format, and that's difficult for people. They can't exploit that, they can't use that. It's too difficult to integrate with other sources as well. So this is the reason why we, in the middle, have this implementation of an enterprise data warehouse. So that was not that technical, let's say. If we translate that to an AWS architecture, how is it looking? So we still have the sources on the left. The realization of the data lake is, of course, based on S3, which gives us a lot of capabilities to do all that and to manage all those things. For some large and heavy processing, we use Amazon EMR, the big data cluster, to crunch and to do a translation of a format, for instance. But we keep the data in its native or pre-processed format inside the S3 storage. From there, we go to the right to Redshift, where we clearly opted for a modelization technique, which is called a data vault 2.0, which makes it possible to always extend your data model and not have to start over for a new use case. So that was very important for us. On the right, on the bottom, you see that today we have, let's say, 500 analytics consumers. That's a lot, but it goes even further than that. The architecture or the data platform is also capable of exposing data towards third parties via APIs. That's a specific use case. But also the same picture is in fact possible to integrate with the call center. In the call center, people take the calls from a customer which has an interruption of his service. They need very, very fast statistics about all items that the customer owns, with statistics up to the last 7 days. And that needs to be very detailed, but also they need it on the screen in a sub-second response time. So this is why we used a NoSQL technology there, but it's completely integrated in the picture, and that's important. Okay. So let's say the results of this architecture, this data platform, it's definitely, we can answer any analytical use case, but it goes also beyond the typical analytical use case or where BI goes. It definitely adopting a well-defined structure of doing things and the processes which comes with it. It makes it possible to develop faster and to work in a large team as well. So that's important also. Okay, and yeah, of course the users get now much faster results and less technical stuff or technical IT challenges, let's say, and all that is GDPR compliant by default. Okay. This brings us to the next steps.
Yeah, and then so just to presentation, let's say on the next steps. Well, we started in 2017, so a transformation of this size will take in our company about 2.5 years. So if you start with it, because this is a real transformation, takes some time. So what we are doing right now, and we will finalize the project more or less by the end of this year, and then we are really in operation. So we are integrating the last sources because we have up to 50, 60 sources of data coming in. So we are still working on the last ones. We are, let's say, finalizing the remaining use case because the business, of course, now needs to migrate their reporting or their analytics or other flows they are using to the new system. So it also a lot of effort on the business side so that we can decommission the legacy, because the real gain will be there if we can stop using all the legacy systems. So that will be one of our major objectives for 2019. Then, of course, we are launching new products all months or several times a year. So we have to integrate every time new data sources internally, but also external data sources from our partner products that we launch. Because the project is let's say, working well, we have now also a lot of interest of our partner company in the Native group. Let's say the press people from L'Avenir are also interested to use the same tools, and we are setting up a similar environment for them. And also the utilities are looking at this because the utility sector, the electricity sector, has also a lot of data to manage with smart metering. So the system is usable also not only in the business of telco, but I think in any other business. And then, of course, while setting this up, and this is already the case now, we want to also support business in much more complex and challenging business use cases, where we start using also testing the machine learning capabilities of the system. Thank you very much.
Thank you. So the cool thing, the thing I really like about this presentation, apart from everything, because I talk about building things, but they really build things, is like, if you notice, they are using a lot of the services I was talking about, but then they choose to use open source things like Airflow, third-party partners like Tableau, other third-party partners like Matillion, and that's pretty cool. I mean, you don't have to use all the services I've been talking about. You have to choose the ones that make sense for you, and if you really have something else, integrate. So that's pretty interesting, because sometimes you can get the idea, there are too many things, I'm never going to learn those. You don't have to. Just pick the ones that make sense for you. So now I have about 3 minutes to do a demo. And it's like, I don't know, Javier, are you going to be able to do a demo in 3 minutes at the Lake from scratch? I think so. So let's see. Can you still hear me? Yeah, okay. Maybe not, but let's see. So I have this data set, and you have the, on the slides, okay. So on the slides, you will also get this. I have a data set, public data set from the New York Taxi and Limo Commission. They basically have like a 1.4 billion taxi rides on CSV on different schemas, which is crazy, but it's pretty cool. I'm not going to be using the 1.4 billions because that takes about 3 minutes to process, and I don't have 3 minutes. But I'm going to use a smaller subset of data. So if I can open the browser, here it is. So that's what I'm spending a lot of money. That's okay. Okay, so that's my S3 bucket. So I have some data on S3, which is like, the information about the taxi rides. So I have here a couple of months of data, CSV files, one per month, of 3 different type of vehicles. So I'm going to the glue catalog, and I'm going to do this. I'm going to create I'm going to catalog new data. I'm going to call this the demos, I cannot type. Okay. Demos Brussels. Cool. That's out of the way. And now I'm going to create a crawler. I'm going to call this Brussels. The hardest part is typing, really. Oh, that already exists. Okay. Brussels, I was doing on the train, I was Brussels 2. Cool. So I'm going to have Brussels 2. I'm going to get data that is actually on S3. So I go to the bucket I told you before. I have my data here. Okay. And I need to choose some permissions here. And I want to store this on the database I just created. And I can execute this already. So I can say, OK, make sense of the files I have on that database. It's going to take about 1 minute. On the meantime, while we finish, let me just show you. Oh, actually, yeah, I have here another one I can show you on the meantime. So if I can. Actually, let's see how it's working, because maybe it finished before I have the chance to go to the others. So let me just, internet, are you with me? And go to the internet. OK, so this is still starting. It will take a little bit. So let me just go here to my tables. I can go to the database. Here, oops, database. I cannot click really. New York City TLC. These are the tables that we'll find. And here you see, you have the schemas, the properties, which fields I have on different tables, and so on and so forth. So if I go back to my crawler, this already had 3 tables. This is the one, this is the one that is still running. Come on, man, you're still running. You're taking a long time. You're taking over 1 minute. So hopefully, Brussels 2, still running, still starting. Well, while it finishes, I'll show you what we're doing. But while it's finished discovering the data, and I'll show you the data that it's discovering, I'm going to show you the part about analyzing data graphically, the dashboard. So once the data is there, and I show you how the data is there, how you can query with SQL, you will have a dashboard that you can create things. But let me see how it works. I can add here a new visualization, easy one. I'm going to be adding here, I'm using data that I have from another run. So I'm using the date time when I was getting customers. So this is this is all the taxi rides I have on the database. And that's the visualization, pretty boring. But let's add machine learning. I want to predict the next 20 days based on the data I have on the database. And I click here. And that yellow part you see, when you see it, is actually machine learning. It's a prediction based on the input data directly on the dashboard. I don't have to write anything. It's just a forecast based on the data I have. I have the same thing for anomaly detection. I can create, tell me, detect any anomalies from the dashboard. And it's telling me, oh, I expected to have in New York for this particular date, $4.4 million in rights. But I have only this, anomaly detection, forecast, machine learning directly on the dashboard. You haven't to do anything. So let me just go back to the crawler and see what it did. And with this, we'll finish. Let me see where you are. If I can click here. Brussels 2, it discovered already 3 tables. That's good. So I can go to my databases here. I can go to the database Brussels 2. Brussels. Why I have Brussels here? Default Brussels. Oh, demos Brussels, sorry, that's the database. I can see the tables, and I can see I want to query this particular table, for example. Show me the data. I didn't do anything. I only had the CSV. I told this to work. It's going to tell me, I'm going to open Athena. You want to open Athena? You will have to pay for the query. That's fine. OK, that's the data. So I have the CSV. I don't know which schema. It discovers the schemas. It allows me to query. It allows me to connect to the dashboard. And I don't have to do much. Same thing with transformations. Same thing with data science. That's kind of the experience you get when you forget about the infrastructure and you can focus actually on the business. So that was the demo I wanted to do. I mean, I have like, an extra thing, but that was basically the demo. And last thing, because I'm already over the time, if you are thinking about building a data lake today, just for you to know that things get even easier because we announced in December, we have lake formation, which is basically a product that allows you to do all these things in an easier way. It's in private preview today. If you want to use it, if you have the use case for building a data lake, don't start building a data lake from scratch today on AWS. Ask me or ask your account manager or your partner. They are going to help you enter into the private preview so you can use already the lake formation. In lake formation, you point the data to the original data, and lake formation uses machine learning to learn from you. It will actively ask you some questions, and it makes all the automation even easier that I saw you, and it also makes sense. Security and permissions are part of the discovery. And that's, as I said, it's in private preview, but you can already use it. We have some customers using it already, and it's quite cool. So thank you for your attention. Any questions you have, I'm going to be around, and you have also my Twitter.